Okay, let us start with multiplexer. So here in this particular session, we will be discussing about 2 is to 1 mux, 4 is to 1 mux, 8 is to 1 mux, and 16 is to 1 mux. Through this session, just I'm discussing the programs and the execution. Actually, I'm sharing with you this in the manual format, and in the another videos, I will show you the execution. So first of all, because simultaneously if I am typing and then showing the execution, it will be a little bit difficult for me. So for this reason, I'm sharing first of all the program part, and also here I have stored the results, and then through tool also with our Xilinx software, we will go through it in another video. So as in the beginning, we will start with 2 is to 1 mux. So simple, in the beginning we need to declare about the libraries. So IEEE library, and then std logic 1164.all. So these additional two packages also I have added here, but actually they are not needed in general. This second one is sufficient because here we are using standard std logic data type in the program. Now this is entity. I have given the name mux2 is to 1, and my select line is name, signal name is S, input is X, and output is, say for example, Z in this program. So here it is select line single bit because it is 2 is to 1 mux, so only one bit, either 0 or 1, and input will be 2 bit, so 1 down to 0, and output is single bit again. So as here I have used if else statement. I have tried to use different statements and styles while writing these multiplexer programs. So in this first program of 2 is to 1, I have used if statement. So after architecture, there will be begin, then process, and we are going to make the process sensitive to select line. So that's why I added here S. As a our general practice, you can add here input as well. So S and X, both the signals which are in mode in, you can add in the program. Then there is begin, and if S is equal to 0, then Z is assigned equal to X of 0. That is, from X of 0 input, it will appear at output. Else if S is equal to 1, then Z will get the value corresponding to X of 1. So this is very simple logic. End if, and then end process, end behavioral. If you look at the RTL, then it will something look like this, because it is based on the selection either or, and then the output. For example, I have set select line 1, and my input is, I have given here X as 0 1. That means my X of 0 is 1 and X of 1 is 0, and therefore if you see the output Z, then it is coming 0. So understood? This is simple 2 is to 1 mux. If else statement, same program. If you want to write for 4 is to 1 or 8 is to 1, simply change here, instead of 1 down to 0, you make it 4 down to 0. 3 down to 0 for 4 is to 1 mux, and 7 down to 0 for 8 is to 1 mux. And here you will have to add respectively, based on select line logic, the statements if and else if. Okay, I will go for another mux, that is, say for example 8 is to 1 mux. Here I have used different statement. So in 8 is to 1 mux, same fashion, in the beginning I have added all these library and package information. Then entity, I have given the name mux81 is. Here my input is W, and std logic vector 7 down to 0, because 8 input lines. Select line, definitely we will need 3 lines, so therefore P in std logic vector 2 down to 0, and then the output Z, that is out std logic. So in the architecture, we will have, say for example, I am using here with select statement from VHDL. Very simple. The syntax is with, then whichever signal you want to make it sensitive with that particular signal. So that particular signal will be, signal name will be written here. We want to make it with respect to P, that is select line. Since there are 3 bits, and we will have 8 different combinations for select line, starting with 000 to 111. accordingly from input we are going to assign to output Z, that is W of 0 when select line is 0 0 0, W of 1 then when select line is 0 0 1, W of 2 when select line is 0 1 1, and so on, and W of 7 when select line is 1 1 1. And as an others clause, we will write here Z when others. You can see here, this is capital Z, which is indicating high impedance state from our standard 9 value logic of VHDL. So this is end behavioral. So this is a syntax and style of writing with select statement. Here there should be single variable, or rather the we'll call it as a say the signal with which we want to get the selection. Then every statement you need not have to write every time the assignment respectively, but only in the beginning for the first statement you have to use this assignment operator and you have to assign. Afterwards, based on our when whatever is the condition, accordingly automatically it will get transferred, and all the statements whichever we are writing under this when construct, they are all terminated using comma, and the last statement should be terminated with semicolon. So this is a style for writing with select statement. And since it is 8:1 mux, so there are total 8 combinations. Accordingly, we have used 3-bit select line and we have written the code. Now you can see here for 8:1 mux, because of with select, this kind of a structure in RTL you can see. And now the output window simulation result. So input is, say for example, I have given 1 0 1 0 0 0 1 1, whatever it may be, one combination I have just given. And then according to select line, so my select line logic is 0 1 0, meaning is that I'm talking about, you can see here in the program. So 0 1 0, that means it corresponds to W of 3. Now here in the input, this is W of 1, this is W of 0, then W of 1, W of 2 and W of 3. W of 3 is 0 and therefore output line it is showing you 0. Okay. So this is one combination, just one result I have added here. Now we will go for 16:1 mux. But before that, I will share with you first of all 4:1 mux, and then we will go for 16:1 mux. Let us see here 4:1 mux first. So this is 4:1 mux. In this, this is our input W. Again 3 down to 0. P select line 1 down to 0 because there are 2 select lines, 4 combinations, and output Z. Same with select logic I have used. With P select, Z is W of 0, W of 1, W of 2 and W of 3 when the combination is 0 0 0 1 1 0 and 1 1, and when others you will get high impedance state, that is Z. Now same style we can use for any other multiplexer logic.